Welcome back, everyone. This is Mrs. Hutchinson, aka Chapa again. We're going to be learning a little bit more about the scientific method itself. We're going to finish up this packet today. So, we've talked a lot about the scientific method, but we really haven't discussed any examples or how we can take the scientific method and actually use it, what the steps really are. So, the first thing that we're going to do is we're going to go through an example and figure out how to solve it as we learn it. So here's our example. Well, let's come up with, I don't know, Andrew. Andrew can't get a date, which is oh so sad. So we need to help Andrew out and figure out, how are you going to get a date? So the first step for the scientific method is the purpose, the problem that we want to solve. And in our particular instance, in our particular example, we want to solve Andrew's inability to find a date. So this is how we're going to be conducting our research. First step is the purpose. The second step is our hypothesis. Remember, when you're making hypotheses, that it's always going to be an if-then statement. So if we do this, then this will occur. And that statement makes a prediction about how you can solve a problem. It's going to include two variables. Remember, our independent and our dependent variables. So remember that the independent variable is the thing that you change in the experiment. It's called the independent variable because you can do anything you want to it. The dependent variable is the outcome of whatever it is that you did. So it depends on how you change the other one. So in our particular case, it's going to be an if-then statement. So we're going to help Andrew out, and we're going to give him the most basic piece of advice, and we're going to say, hey, if Andrew takes a shower, then he'll probably get a date. So that's the first thing that we want to do. It's an if-then statement. If he takes a shower, then we're going to have an outcome. Then he will get a date. Seems simple enough. I mean, we don't know what's really wrong with Andrew. It might be because he smells. We don't know. So we're doing our best to help him out. So the next step, we have the purpose, then we have the hypothesis, now we have our materials. Our materials is simply a bulleted form, a bulleted list of everything that we'll need to perform the experiment, as well as the quantities of each. So things that we're going to want to list here. Now remember, it's a bulleted list. So we don't know let's say we need a washcloth for showering. It's always a good thing to have. You probably need how much shampoo? I don't know, maybe a quarter size amount of shampoo, quarter size drop of shampoo, I guess. That's always good. Shampoo's a good thing. If you don't have it, it doesn't bode well for you in the shower. Yeah, pretty smelly, so let's go with a quarter size drop of soap. Let's go with body soap. What else do we need to shower? I think that's pretty much all you're gonna need. I mean, you do need water, but we don't know the amount of water. I think that's pretty much it. If I missed anything, well, I guess I've been showering wrong all these years. Seems to have been working for me, but maybe that's why people stay away. You never know. So, we have our purpose, we have our hypothesis, we have our materials. Now let's move on to our procedure. Our procedure is not a bulleted list, but rather a number list. It's an exact description of every single step needed. Now, here's a good rule of thumb. Your procedure needs to be clear enough so that any person possessing common sense but no knowledge of what you're studying can exactly reproduce what you've done. In other words, if you have common sense in terms of chemistry, you don't need to say to me, go get your beaker out of the cabinet. Grab a beaker from your drawer. Grab some tweezers from your drawer. Grab a thermometer out of the case. You don't need to say that. You can just simply say, take the temperature of the sample. Or fill a beaker with 100 milliliters of water. Something like that. So it's got to be an exact description. So let's come up with a procedure for showering. It should be pretty basic. Proceed part 1. Let's say undress, unless you shower with your clothes on, and turn on hot water. Place quarter size body soap onto washcloth. And then 3, lather. I like that word. I think it's hilarious. You never get enough chances to use it. Lather on body and rinse. Step 4 would be to probably wet hair, unless Andrew's bald. And rub quarter size shampoo drops into hair. Rinse hair. Whoop. Next step would probably be turn off water. Six is dry off with towel. Hopefully I didn't miss any steps there. If I did, again, I've been showering wrong for years. Okay. So again, we've got purpose, we've got our hypothesis, we've got our materials, we now have our procedure. Let's talk about our results. So in order to have results, we have to have an objective description of everything that happened in the experiment. In this lab, in any lab, it includes a collection of data. Now, we have a couple different forms of data. And we've talked about them before. We've talked about our qualitative data and our quantitative data. So, qualitative data is data that basically is going to give you a description of what happens, but it doesn't include any numbers. So, basically, if you're talking about washing your hands or something, because that has something very similar to showering. You put soap on your hands, you put it under water, it became all sudsy. So the fact that it created bubbles, that would be a qualitative piece of information. So you could have bubbles formed, or the fact that the solution turned blue, so it went from colorless to blue. It made a screaming sound when heated, so it changed its sound. Or we had an increase in temperature. Those are all pieces of qualitative information. Even though you might not think it's important, it's pretty important to have, because you can't have an experiment without having collected qualitative data. Quantitative data. Quantitative deals with the quantities. You have to have numerical measurements. So in our instances, you want to have a specific amount of every kind of material that you're using. So for us, when we said it was a quarter-size drop of soap, that's the exact amount. If we're talking about like temperatures and weights and lengths, we want to have an exact temperature. Here, this is just us saying, hey, the temperature increased when the two solutions were added. Sometimes that's good enough. Sometimes you want an exact temperature to be taken. The fact that we include a number makes it quantitative data. Now, typically in every experiment, you're going to have a data table. And that data table is going to typically look a little something like, whoops, a little something, oh no, like this. Look at that. I can troubleshoot anything. You'll also find that technology is not my strong suit, by the way. But you'll find that this chart actually deals with the time that you're doing something and then the observation that you make. The last thing that we're going to do after we've collected our results would be to talk about our conclusion. It's a concluding statement. It's a restatement of the hypothesis that either confirms that it was right or states that it was wrong. You never, ever, ever prove a hypothesis. You simply accept or reject your hypothesis. It looks like a G. I promise you that's not a G. So you either accept or reject your hypothesis. Now, that's always going to be your first sentence in your conclusion. I accept my hypothesis because. The general form is in one sentence. Here we go. When Andrew, oh, poor Andrew, showered, he didn't get a date, which basically meant I reject my hypothesis because when Andrew showered, he didn't get a date. Then you're going to analyze what really happened. Why is it? Is it a personality issue? Is it the fact that he's super shy? Is it the fact that he's super tall, super short, long hair, short haired? We don't even know. So you're going to have to analyze what really happened. And typically in there, you're going to include some error analysis. What could have gone wrong? Why might our measurements not match what we anticipated them to match? Now, in this class, you're not going to get very much credit for actually having the right answers or having proved your hypothesis, and this is the term that we will never use, proved your hypothesis correct, or having a correct hypothesis. You're actually going to get much more credit for going through the steps correctly and following the scientific method appropriately. That's more of what you will obtain credit for. Now we're going to do the worksheet, the scientific method worksheet. You're going to read this scenario. It says, it's winter, the power has gone out in your house, and the temperature inside is dropping rapidly. Fortunately, you're taking chemistry, so you know how to use the scientific method to solve your problems. And you're going to answer all of these 6 questions using that scenario. Figure out what your purpose is, what your hypothesis is, what materials you're going to need, what your procedure is. Be explicit. Make sure that everybody who's reading it can follow that procedure. What results will likely happen? You're going to have to use your imagination to answer this one because typically, well, we're not going to test this one today. And then you're going to come to a conclusion. Now, please, please, please be creative here. Use your imagination a little bit. You could say that you're going to light all of your siblings' clothes on fire inside the house because, well, you need to heat it up and you didn't want to use yours. Something like that. Be very, very creative. It's always enjoyable to hear some of the ideas that people come up with. The last question, you're going to think back to some time in your life when you had to solve a problem. Using the 6 steps of the scientific method, describe what you did to solve the problem. So you're going to think about, well, let's see. I had to cook dinner. I was hungry. So, how did you go about doing that? Or, I wanted my hair to be straight, and it turns out that my hair happens to be curly. So, how did you go about doing that? So, really think about it that way. I want you to work on this, and we will discuss it tomorrow. Have a good one.